All right. Welcome. We're going to talk about derivatives some more, specifically looking at the representation of the graph of a derivative. So we're going to sketch f prime if we're given the graph of f. The key word here is that we are sketching and not actually coming up with the exact graph here. So it's okay if our graphs look slightly different. There are some really important things, though, that should all match in ours, and I'm going to be talking about that here today. So here is the graph of f right here. So it's just some, looks like sort of like a polynomial function of some sort. And so I have down here the sketching, or the empty coordinate plane for what will eventually be the graph of f prime. So in order to do this, we will sort of focus in on first trying to figure out some really important points, some like sort of landmark points. And the way we figure that out is through the definition of the derivative. So the derivative is the instantaneous rate of change, or the slope of the tangent line, the slope of the curve, basically. So the easiest thing to figure out first is, when will f prime intersect the x-axis? Well, that happens when the output value is 0. So all my x-intercepts have an output value of 0. So what I want to figure out is, I want to know, when does f prime, when does the derivative give me an output of 0? Well, that would happen when the slope of the curve is 0, when the slope along this is 0. So that would mean that our tangent lines are horizontal lines, okay? So where does that happen? Well, if you sort of follow it along with your pen, if you wanted to sort of get an idea of your tangent lines, that's what I sometimes like to do, is sort of like act like it's some sort of like roller coaster, and here's the cart. So I want to know, when is the cart on the roller coaster track perfectly horizontal? And the first place that happens is right here. Right here, it has a tangent line that is horizontal. So that means that that is the first x-intercept I can plot down on my lower graph. So I'll just actually follow this down, because the way I've set this up is my inputs line up perfectly. So I can just take this and sort of follow it down and go, cool, there is my first x-intercept. Okay, and I can do the same thing, so keep going along. Okay, I flattened out there, now we're going along, and then boom, at this little peak right here is the next time the roller coaster cart is exactly horizontal again. So there it is. So follow it down, and there's our next x-intercept right there. So about 1.5, it appears. Okay, and I keep doing the same thing, boom, and then hit the next place, which appears to be at about 3.5. So I'll just follow that down and plot that point right there. All right, and so there are 3 different places here where the derivative is 0, or that's the slope of the curve hits 0. Okay, so then now let's talk about how to sort of go from here. So I know that whatever this curve is down here needs to go through that point, and that point. So the next thing I need to figure out, though, is, well, in between those points, what is it doing? Is it above the x-axis? Is it below the y-axis? It won't be both in between. If it was like above and below, then we'd have another x-intercept here, since this is a continuous function. So I just know it's going to be positive or negative. So again, I think about that definition. It's the slope. So is the slope of this curve positive or negative in these different areas? Well, the first thing is thinking about here, the slope is negative as we go along here. If you look at my pen being sort of like the tangent lines, it's negative until it hits that 0. So that means down here, I know that I'm going to be graphing negative values. And so I sort of just like to put a little negative sign down in the area to let me know, like, okay, that's where I'm going to start. All right, keep going. So we hit 0, and then now I'm climbing uphill. So it's a positive slope now. So between 1.5 and 2.5, positive slope. I'll just put a little plus sign to remind me. All right, back to negative. So down here, a little negative sign, like so. And then lastly, after this, it is positive and just continues onward. So we'll go ahead and put a little positive sign here. Okay. So now I have a really good idea as to how this will look. So we're going to start down here in the negatives, pop up to the positives, back down into the negatives, and then take off into the positives afterwards. So it looks something sort of like this. And if you miss a point, just make the point bigger, so that way you actually hit it. And there you go. That, I believe, is a good sketch of the derivative of f, or f prime of x. And so it maps the outputs of, or sorry, maps the slope of this function. Notice that I didn't spend a lot of time trying to figure out exact slopes. Like I could come over here, I guess, and sort of draw a slope triangle. Although that wouldn't be helpful because they didn't label the y-axis for me, so I have no idea actually what that would be. So yeah, this is all we're really looking for. Now, in class, we are going to confront ones that have some extra weird stuff going on with it, and so we'll talk about those as well. But this is the basic idea. You try to figure out when does the slope of the function reach 0, when is it 0. That gives you your x-intercepts, and then it's when is it negative, when is it positive, and that tells you when you're above or below the y-axis down here. All right, so go ahead and take the survey, and we'll talk about this next class.